Okay, so we're about halfway through our math skills for physics. I know we started off with how to determine whether a number is significant or not, rounding and scientific notation, and then how to decide what your final answer should have based on significant digits. There's three more things that we're going to look at that are really important to be successful in this class. And the first one is just how to organize your answers when you are asked to submit work for me on a test, quiz, or assignment. There's going to be times where I'm going to give you some word problems. Absolutely, this course is made up of a lot of math and word problems. And you may decide that it's easiest for you to handwrite your answers on a piece of paper, which is fine. I went through this in the introductory material about what's required of you. You can do your answers by hand on a piece of paper as long as you can somehow get them digitally entered into it to be able to submit into a Dropbox. So in the past, I've found that some students are comfortable doing their calculations on the computer, which is fine. If that works for you, then it's already digital. But if you're doing it by hand, which most usually want to, you just have to be able to find a way to digitize it. And the easiest way is a scanner, if you have access to a scanner. But I think probably the most common way that I get them is people taking pictures with their phones. There's actually, if you have an iPhone, there's actually apps that will let you take a picture and it'll turn it into a PDF for you. Because you just need to be able to submit your work into the Dropbox. And I know sometimes when you're working on math style problems, it's easy to handwrite it. So here's the format I want to go through with you guys so that when you're submitting your work, you follow this method. And hopefully you've heard of this before. It's called the GRASP method. And each one of these letters represents how to organize a solution. And they're all actually right down here. But I'm going to spread them out a bit here. Let me just pause this for a minute. Okay, so what we're actually going to look at right now is basically how to approach any word problem in physics that you're ever asked to solve. Okay, you're going to read through the problem, calculate the distance a cyclist travels while moving 12.3 meters per second for 4.33 seconds. So good strategies to use are try to identify what it is they want you to even find just by reading it. So calculate the distance. This is what we need to find. Okay, and they're giving us some values. So the cyclist travels while moving 12.3 meters per second. We're going to become familiar with what the units are so that they help you figure out what it is. This is just an example to show you how to organize it. So don't worry if you're not familiar with what meters per second means yet or how it all fits in. So, but just decoding what they've given you is what is really important at this point. So given, what have they given us in terms of number values? So here's our given. They've given us its speed. So I'm telling you what these variables are. We're going to learn about them in the first unit anyway. So speed or velocity, they've given us. And they've given us time in seconds. So we write our given information first. And here's the thing I always get students asking me, do I have to write the word given? Do I have to write the word required? No, you don't. You just have to get in the habit of showing me this amount of work. It just keeps it nicely organized and it's easy for me to mark your answers as well. So what's required? Required is what they're asking us to solve. They want us to find distance. So we just show that this is what we're solving for. Okay, and the formulas I never told you yet, but you don't have to memorize formulas in this class. There are so many formulas that you will always have a formula sheet to use. So don't worry about that. In this case, I'm going to show you what the formula is. So speed or velocity is equal to distance divided by time. Our analysis and solution is just showing us the correct choice of formula and then putting our numbers in and solve. And you might show a different amount of steps in order to do this, but we're going to put our numbers in now. 12.3, and we're solving for our distance, and we are given time. Now, hopefully you can rearrange equation like this, but that's the next lesson to be covered. We want to solve for d, which means we want it on one side of the equal sign by itself, and the way that we get rid of or move things is by performing the opposite operation. So if this 4.3 is being divided on this side of the equal sign, in order to move it to the other side, it needs to be multiplied. Multiplying is the opposite of dividing. So in order to just solve for d, it gets moved up here, so 4.333 times 12.3. And our final distance ends up being 53.2959. Now, here we have our final answer. This is what our calculator has told us, but is this what we include in our final answer? And the answer is no. We have to always ask ourselves, how many significant figures should we have in our final answer? Where do we look? We look under our given values, the numbers that they provided us in the actual word problem. So let me use a different color. This has 1, 2, 3 significant figures. This guy has 1, 2, 3, 4. Our answer can only include the least number. So that means our final answer has to have 3 significant figures, which means we have to round this. And so therefore our overall final answer will be 53.3. And don't forget your units in meters. And the other thing I like to suggest to students as well, it's just easier for me, is to draw attention to what you are calling your final answer, okay? By putting a box around it, underlining it, doing whatever. This is how I know where to go to see what you've decided as being your final answer, rounded correctly to the correct significant figures. Okay, you'll still get part marks if you've left it like this, but try to get in the habit of determining your significant figures and drawing attention to it by putting a box around it. Paraphrase just means a therefore statement, which most people don't love. So therefore the distance is 53.3 meters. Now here's the deal I usually make with most of my students. If you've put a box around your final answer, I don't need you to paraphrase it, because paraphrasing is really just another way of drawing attention to what your actual final answer is. So this or this is fine. I don't mind. You don't have to do both. I just want to know what you're telling me is your final answer, and that's it. So that's kind of the format I want you to follow for all problem-solving type questions. Okay, second last thing I want to go through with you is how to convert units. So because we're working with all different types of units, we need to be able to know how to convert between one to another in a whole bunch of different ways. So in terms of length, time, anything. And this one method that I'm going to show you will work for conversion of any units at all, as long as we know some sort of common relationship. Okay, so I think the best way to go through these is to just work through an example. So a common example you're going to see in this course is you might be given a speed of some sort in kilometers per hour. So let's just say 40 kilometers per hour. And we're going to learn about what standard units are. So standard units are just a standardized way of expressing different things. So speed or velocity is always expressed in meters per second. So meters is the standard unit of length. Seconds is the standard unit of time. So if they gave us something in kilometers per hour, we need to be familiar with how to convert it to the standard form, which is meters per second. And so the method I'm going to show you is probably the most valuable thing I've ever learned. And I didn't learn it until I was in university, but now it's being encouraged to teach you guys now. And it was one of the best things I've ever learned. So if you can get the hang of it, it takes some practice, but it gets to become very easy once you start working with it. So how you start it, you're using related ratios or fractions. Remember, a fraction and ratio are the same thing, to help cancel out units that we don't want, and then to work towards units that we do want. So what we want to try and get rid of is we want to get rid of our kilometers into meters and our hours into seconds. So we want to think of all the relationships that we know about. And these are things that we should know, hopefully. They're not going to be on a formula sheet for you. So here's how you start. You take what you're given, what you're starting with, and you write it as a fraction. So 40 kilometers per hour as a fraction is 40 kilometers over 1 hour. Okay, and what we want to do is slowly move these units to the ones we're getting to, or what we want as our end. So kilometers, we want to convert those to meters. So we have to think of the relationship between kilometers and meters. Well, we know that there are 1,000 meters is equal to 1 kilometer. How can we take this relationship or ratio and write it as a fraction so that this kilometers will cancel out? Well, if you remember for fractions, divisions, multiplication, anything on the top of a fraction is canceled out by its same unit on the bottom of a fraction. So we just have to figure out how we can write this relationship so that the kilometers cancel out. Well, 1 kilometer then needs to go on the bottom so that these two cancel each other out. And in our 1 kilometer, we know there's 1,000 meters because they're the same thing, right? 1,000 meters is 1 kilometer. So we just need to write it in this fraction so that we can cancel units out. So once we cancel kilometers out, now we're left with meters. That's what we want in our final answer. We want to now do the same thing with hours. We want hours to become seconds. So let's think of the relationships that we know. In 1 hour, there are 60 minutes, but we don't want minutes, we want seconds. So we need a couple of relationships. In 1 minute, there's 60 seconds. So now we're going to use these two fractions to help cancel out our hours. Well, how are we going to get hours to cancel out if hours are on the bottom here? It means we want, on our next fraction, we want hours to be on top. So in 1 hour, there are 60 minutes. And you'll notice hours on the top of a fraction versus hours on the bottom cancels each other out. It's like saying hours divided by hours or 2 divided by 2. Remember, anything divided by itself is 1 and cancels out. So now we're left with meters and minutes, but we want meters per second. So the next thing we want to do is use our last relationship. We want to get rid of the minutes, meaning we want to cancel them out. So we write minutes on the opposite side of our fraction sign. So 1 minute, there are 60 seconds. And now our minutes cancel each other out. Now we're left with these 2 units, which is our goal. That's what we want in our final answer, right? We wanted meters per second, and that's exactly what we just did. By using relationships that we do know to cancel out ones that we don't want. Once you've gotten to the point where you know you've got the units you need, you can look at this in a couple of ways, and this probably is the easiest way. You can look at this as one whole big fraction line, in which case you're just taking all the numbers on the top and dividing it by the multiplying of all the numbers on the bottom. And so what you end up with is 40,000 on top. And remember, our units we were left with was meters up there, and we're left with 3,600 seconds on the bottom. And so therefore our final answer is 11.1 meters per second. So what does this tell us? That if you're traveling at 40 kilometers per hour, it's the same thing as saying 11.1 meters per second. We're just taking one unit and converting it into its equivalent of another. Okay? I'm going to give you one more example because this tends to be tricky, and then you're going to try some of these on your own. Example, so let's just, what if we're dealing with just one unit? 453 seconds, convert that to hours. Okay, so the same method you start with what you're given. There's no fraction here to work with, so we can turn it into a fraction by just putting it over the number 1. Okay, we want to go from seconds to hours. We're going to use these same relationships that we used up here. 1 minute is 60 seconds, 1 hour is 60 minutes. And how do we arrange them? We arrange them so that we've got the one we want to cancel on opposite sides of the fraction sign. So there are 60 seconds in 1 minute, and that cancels seconds out. And we're left with minutes, but we want hours, so we got to do one more time. There are 60 minutes in 1 hour, and that cancels out our minutes. We're left with just hours, which is what we want. And now we just complete the operation on the top, divide it by the operation on the bottom. So we are left with 453 hours. And notice how there's no units on the bottom, which is what we want. And we end up with 3,600. And so therefore our final answer is 0.126 hours. Now, it's good to get in the habit, too, of our final answer. How many significant digits should our final answer have? Well, what did they give us? They gave us 453. There's 3 there, so our final answer should have 3. So that one's good. If we come up here, there's only one significant figure here in our given information. 40, there's no decimal point, so this trailing 0 doesn't count. So technically, it's just one significant figure. So technically, you would round this to 10 meters per second to get just the one significant figure. Okay, so here we are at the final step of our math skills. And the final thing I want you guys to be comfortable doing in this course is to be able to rearrange equations. We know that if we have an equation and we plug our numbers in, it's not always necessarily the one that we're solving for that is what we're looking for. So we have to be able to put our numbers in and potentially rearrange if we're solving for something in a different position in our formula. I'll show you an example so that it helps make sense. So we'll just take the perimeter formula. So the perimeter of a rectangle. The formula looks like this. Perimeter equals 2 times the length plus 2 times the width of our rectangle. And we want to solve or rearrange for width. So let's just say we were given numbers for perimeter and length, and then we had to rearrange and solve for W. This is something you're going to commonly have to do throughout this course. So what I'm showing you now is how you rearrange before you put any numbers in. I personally don't like to do this because it's extra steps. I'd rather put my numbers in first, simplify what I can, and then you have less rearranging to do. But these rules apply regardless of what method you take. So the first thing you want to do is move terms that are separated by a plus or minus first. So think about this. This is the one, when we say we're solving for W, what that means is we want it on one side of the equal sign all by itself. And right now it's being multiplied by a 2 and added with a 2L. So first step says move terms that are separated by a plus or minus. This is our first step. This is a term, okay, a term that is separated by a plus or minus from the one we want by itself. So the separation or movement of it, like I said earlier, is to perform the opposite operation. Right now, this term is being added with this term. So in order to move it to the other side, it needs to be subtracted. So I'm going to show an extra step here. This is something you may be very comfortable with, which is fine. You don't have to show it, but I'm showing it for those that this is maybe a little bit new for. So we want to subtract it from both sides. And I'm showing this extra step just to show you exactly what is happening. Okay, so what happens here? 2L minus 2L gets rid of it on this side but moves it to the other. And that's the whole idea behind moving things from one side to the other. By performing the opposite operation, you're canceling it on one side and you're bringing it over to the other. So what are we left with? We're left with P. Whoops, let's get our black pen back. We're left with P minus 2L on this side is equal to 2W. And the final thing says, separate the remaining desired variable by multiplication or division. Well, right now, we want to get rid of this 2. It's being multiplied with the W. So in order to do that, the opposite operation would be to divide it. So we want to divide both sides by 2. And again, on one side, it should cancel itself right out. And then you're going to write what you're left with. Now this would be what you would be doing if you had to solve for W and you were given values for P and L. One last thing I just want to point out as well. We are used to seeing the variable that we're solving for on the left-hand side of the equal sign. It does not matter. See how we've simplified this and we've got the one we're solving for on the right-hand side? This means the exact same thing as if you just reversed it, if you're more comfortable seeing it over here, which is fine. These two mean the exact same thing. We're just switching sides. As long as we keep what's on the sides the same, you can reverse which sides they're on. They mean the exact same thing. Okay, and so that pretty much sums up the math skills that are required. And I know that this is something we're probably going to have to review as we go, but these are the sorts of things I just want you to maybe spend a day or two practicing so that you can get comfortable and then iron out any issues by asking questions, or I can go through anything else that you want to.